Right, hello, and this is another C2 video we're going to be doing today. This one is about binomial expansions. It's going to be about finding certain terms, and I'll go through a few past paper questions you need to understand. Alright, okay, so the first thing we need to ask ourselves is, well, what is a binomial expansion? Well, it's just an expansion that has sort of a bracket. So, for example, I'm going to start off by giving you a certain, let's think of it. It's just like, it's binomial expansion, it's just a way of, it's sort of a formula of, you know, like normally you'd have 2 plus x squared, for example. You could do that, just put 2 brackets next to it. I'll do up here. So we said 2 plus x and in brackets squared. So basically that is the same as 2 plus x in brackets times by 2 plus x. And obviously, you know, you could simplify that out. So just for the sake of doing this, that would be 4x times x plus x squared plus 2x plus 2x plus 4x. So that would be the same as that. And now you could keep doing this, going through. So 2 plus x cubed, and you just do that again, except have another one in there, and you keep going. But the thing with that, it'd probably take quite a while for you to do. So if you got into the exam and it said 2 plus x to the power of 100, if you tried to expand that, it'd take you an awful long time rearranging, and you'd likely to make some mistake. So that's where this binomial expansion comes in. Right, okay. So I'll just leave this on the board as sort of why we're doing this. That's sort of like an introduction to the sort of topic, if you like. Just make sure you can see that. Yeah, so that looks alright from here. See if I get a different pen actually. This one should work a bit better. Right. Okay, so we've sort of got that out of the way. Why we use this sort of formula, and I'm going to show you now. Sort of, it is given to you, this formula around now on the board. It's given to you in the Edexcel C2 paper. It's like the formula page, but I'm going to write it out anyway. So you may get something like this. It says N R brackets. And that is the same as saying NCR. Is that the right way? Oh, big C. And what that's basically saying, that's a binomial coefficient. So it's like the third term in the series, for example. And NCR, this is the same as saying, if you're going to work it out, it's the same as saying n factorial over r factorial, n take r and the factorial of that. So basically n factorial, r factorial, n take r and the factorial of that. You may go, well, what is a factorial? It's quite simple to understand. Say if we're doing, for example, the factorial of 2. That is the same as 2 times 1. Basically, so you go down by 1 and you times that number by the previous one. So 2 times 1, so 2 is that number, to take away 1, times it by 2, and that gets the factorial of 2, which is just 2. Now if we did the factorial of 3, it's 3, take away 1, times it by the previous one, which is 3, so 3 times 2, take 1 away from 2, which is 1, times it by 2, and if we times all that out, 3 times 2 is 6, times 1 is 6. So the factorial of 3 is actually larger than 3. That's generally the case. That first one was just coincidence that the factorial of 2 happened to be 2. If we did the factorial of 4, that'd be 4, take away 1, be 3, 4 times 3, 3 take 1, times that by 3, you get 3 times 2, times 2 take 1, which is 1, and you times it by 2. So 4 times 3 times 2 times 1. 4 times 3 is 12, 3 times, 12 times 2 is 24, times 1 is 24. So that's just how to work out the factorials of each number. Now there is a lot simpler way. You don't need to use that formula. You use that. I'll tell you in a minute why you use that when we're expanding one of these and how it relates to that in a minute. But if I just went and told you the sort of formula and it had this in it, and you go, well, how do you work that out? I'm just explaining it to you. It's sort of when we look at the formula, you understand where we've got that from. So that's a factorial. That's how to work out a factorial, and you just put that. So n would be this number here, r would be this number. Now NCR is also written like that. So it could be, I'll just do an example here, 3C 2. So n is 3. So I just put n equals 3, r equals 2. Yeah. So if we were doing the factorial of 3C2, then it'd be n3, so 3 times 2 times 1. Put it into this formula here, over the factorial of r, which is 2, which is 2 times 1, which is just 2. 2 times 1, in brackets, n take r, 3 take 2 is 1, and the factorial of 1 is just 1 times 1, which is 1. So if we expand that out, 3 times 2 times 1 is 6, so that's 6 over 2 times 1, 2 times 1 is 2, and that gets us 3. Now there is a simpler way of finding this one out, so I'll just zoom in so you can see what I'm pointing at if you can't see it. So that is the way of finding out when that's like the first term in the sequence of the binomial expansion, which I'll go on to in a minute, so don't worry if you don't get this yet. All I'm doing is just showing you how we use that formula when we're finding a term. Now that is not a term that I found out. All that is just basically sort of the first step into the formula. And I'm showing you how to work it out instead of explaining it halfway through a term. Okay, so that's like sort of the introduction thing there a little bit. Alright, so we've got that. Now what is an easier way of working this out? Now, you may have heard this around the world, but we've got something called Pascal's triangle. And hopefully, if you don't mind, I'm just going to rub these factorials off here, because hopefully you know how to work out a factorial now. So, how can we use Pascal's triangle to work out like 3C2? So say for example this is it. So it's 1, then 1, 1. So basically, and this is 1. You always start with 1 on the sides. So at the top we start with 1 because that's only in the middle. 1 at the side, 1 at the other side, and then what we do is we add this number and this number to get us this number. So 1 plus 1 is 2, and 1 plus 1 is also 2. And we put 1 at the side. Just make sure I'm doing this right. Just give us a second. Oh, 1. Sorry, just. No, not right. Yeah, sorry, no, I don't need to write two twos there. So basically, we add that, we add these two together to get 2. Then we put 1 on the side, we put 1 plus 2 is 3, and 2 plus 1 is also 3, and then put 1 on the side. This is just how to work out Pascal's triangle. So you start with, you always put 1 on the side. So we start with 1, and that's the only one we've got there, so we've got to have 1. Put 1 on either side, so we've only got the sides, and then we add the 2. Add the numbers in between the 1s, and add the 1. So we add each section as we go down. So we put 1 again on the side. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then put 1 on the side. We keep adding 1 on the side. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, which is 10. 4 plus 1, 5, 1. I'm sure I've done that right. Yeah, so that is, I mean, it does go on Pascal's triangle past that little bit there. See if you can actually spot that. Yeah, you can. So it does go past. So basically, I'll zoom in. So you put 1 on the side. You add 2 plus 1 there to get that 3. You add the other 2 plus 1 to get that 3. And then you put 1 on the side. And then you put 1 on the side again. 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then you put 1 on the side. And you keep going down in the same fashion. Now that is like the sort of the really basic sort of start to it. The binomial expansion formula. So how can we use this to work out this? So we know 3C2 is 3. So we can't start on the first one. So basically, if you take away 1 from this, so you got 3C2. If you take away 1 from 3, you get... Wait. Sorry. Yeah. 3, 2... Right, wrong way around, sorry. So if you've got 3, if you've got the number 3, obviously 1C0 does not start on the first row, it starts on the second row. So basically, whatever you've got, so you've got 3C, 2 on the bottom. So if n is 3, like we've got there, you add 1 to that, so it starts on the 4th row. And if we do this for the 4C2, it starts on the 5th row. 5C2 starts on the 6th row. So if we look for the 4th row, and the R is a number along in that row, so 3, so we add 1 to get 4, is a second number along in the 4th row, should give us 3 as we've worked it out there. So we look, first row, 1. Second row, 3rd row, 4th row, and that gets us R3, which I've circled there. So that's how we work it out. We can just draw a Pascal triangle. We don't need to faff around with this bit, but that's just proving to you that 3C2 is in fact 3. And we've worked it out using the formula, using this one, which you're given in the exam, to get that 3 there. So you can see how we're linking this together. Okay, so hopefully I've explained that rather diddly than doodly. So quite well. How do we apply it to this? We've still not gone over the expansion, the pure reason for this video. This is part of one of the first terms in expanding an equation like this. So there are 2 sort of formulas you can use. One of them, I mean, that is not a formula for expanding, that is just a formula for finding NCR. It's just a formula for finding NCR. It's not a formula for expanding it, it's just a formula for finding NCR. So, what are the 2 formulas that we use? Well, one of them, for expanding it, you use for positive integers only, but the other one you can use for any integer, any number. It could be positive or negative or, you know, not full, I think, not whole, not in the integer. But generally, in the exam, they're giving you positive integers. Now you may be asking me, well, why do we use why do we have 2? Why do we just have one that does everything? Well, the one that does positive and negative and half, it's sort of it's a couple of guidelines you have to follow is 1 plus a. So you have to have 1 at the start. So a is the second number. So as 1 is not at the start, I mean that x up there could just be a number. Generally that's what it is. As we've not got 1, we can't use that. We have to use the other one, and it's 2 up the side. 2 squared even. And there is a method of rearranging it to get the 1 at the beginning, which is you're just dividing it. So if you've got 3 plus 2 squared, you would just divide it by 3 to get 1 at the beginning, for example. So let's I think we'll start with I'll get rid of all this on the board. Hopefully you've got that down, just give me a bit more space. Okay? So I just need a bit more space. I'll leave this on the board here. Actually, you know, I'll leave Pascal's triangle as well. 1, 5, 10, 10, 5, 1. And that, just leave Pascal's triangle on the board. I'm going to just draw a line under here. I'm going to do our work. So, it's asking us, one of the questions, it says, obtain a binomial expansion of the following. 1 plus 2x cubed. Now, we could do this method and put in 3 brackets there, but the formula you use, as this is, I'll just put the formula underneath. So this is A plus B to the power n. And that is equal, this is how you expand it. So we've got A is equal to 1, B is equal to 2x, and n is equal to 3. So we've got n from there, b from there, and a from there. Now what we do is we do the NCR, so NC 0. As we always start with 0, so this 0 is the one along there. Because anything with 0 at the bottom is just going to be 1. And then we add each of these, and then we times that by a to the power n, and we times that by b to the power 0, and we add n c 1 times a to the n take 1 times b to the 1. Now you say, and this carries on, by the way, that's not stopping. You say, well, when do we end this at the bottom there? Well, I'll tell you when we end it. It's when this number equals 0. So it's when n equals so it's when the number above a, so a to the power 0 is going to be 1, and you can't take away, well, you can take away 1 from 0, but you can't do anything to the power of, well, you can actually, it's not a good example. You stop whenever this equals 0, otherwise you'll be timesing it by minus a half, and you can't have minus a half as like a binomial expansion, sorry. So that's when we stop this formula. Now this is great, this works for positive integers, no problem. So I'm just going to do this now. I'll leave this bit on the board here, and we'll do it in this method. So n, which is 3, c 0 times a to the power n, which is 1 to the cubed, 1 cubed times 2. Now this b, you don't carry the x along, because that's, you can't sort of cube x, can you? I don't think you can. Let's check. So let me just yeah, no, I don't think you can. So let me just do something. Oh wait, you can't, yeah. So just give me a second. I'll be a minute, sorry. Yeah. Times 2x to the 0 plus 3c1 times a to the power n take 1. 3 take 1 is 2, so plus 1 squared times 2x to the 1. And then we carry this on, so 3c2 times a to the, so 1 to the power 1 times 2x squared plus 3 to the 3c times 1 to the 0 times 2x cubed. And if we expand this out, so I get rid of this bit on the bottom, so I've got a bit more room when we're going over this. Now, as I said, this is the formula that works for positive integers only. So you'd only use this if it was a positive power, which when n is positive, that's when you use this power, this formula. So expand this out. 3c0, so we look for the fourth row and the third one, so that's 1. 1 times 1 cubed, 1 times 1 times 1 is 1, so 1 times 1 times 2x is 0, anything to the power 0 is 1, you should know that from your indices work. 3 to the c1, this is 3, times 1 squared, 3 times 1, 1 squared, which is 1, times 2x, times 2x to the power 1 is just 2x, plus 3 to the 3c2, and that's 3 again, 3 times 1 to the power 1, times, which is 1, times 2x squared, which 2x times 2, 2x times 2x is 4x squared, plus 3 to the 3, which is this one at the end of the fourth row, and that's 1 times anything to the power 0 is 1, so, and then 2x cubed, which is 8x cubed. And if we simplify this down, so 1 times 1 times 1 is 1, plus 3 times 1, which is 3, times 2x, and that gets us 6x. 3 times 1 times 4x squared, 3 times 1 is 3, times 4x squared, so 3 times 4 is 12x squared, so plus 12x squared. 1 times 1, 1 times 8x cubed, it's just 8x cubed. So that is the expansion for this. Now, we could sometimes, sorry, I'll just move out of the way. I'm going to prove to you that that is the case. Well, actually, I probably won't, I don't have the time to try. Right, so you can sort of see what we've done there. It might ask you some questions. It says, put it in descending powers of x, which you just flip it the other way around, or ascending powers, so it's getting smaller. Descending powers, so it'll be getting smaller, you just flip it the way around, or ascending, which is that one getting higher. It just depends on what the question's asking. But if it's asking you, before I go into the other sort of term, the other thing, other formula even sometimes it may ask you to find the third term in a seek. See, I'll just get rid of this. So hopefully you've got pause that. So get rid of that. So it might ask you Well, what is the third term in the sequence? Now you could go, what we've been doing there, as add this, add that, add this. What was that? Was that sort of what we're doing to? Would you just go, and then obviously this would be your first term, that'd be your second, and that'd be your third, and you just go to however many terms it wanted you to go to, and you could do it that way. Let's see. Sorry, I'm just seeing if I've missed anything out in the book. Just give me a second. Coefficient 1 squared. Sorry, I'm just seeing if I missed anything. I don't think I have in that one. Oh, it's cubed. It's the power cubed. 7 over. This one I was looking at does seem a bit of a handful. That formula that I've gone through there, it does give it you in the formula sheet, but I think it looks a lot better the way I've done it and the way I've explained it. But you can use either formula. It doesn't matter which one you use. Both get you the same answer. This other one I'm going to go through now. So I'll use the same expansion. Okay, so 1 plus 2x cubed, because that fits the other criteria of the other formula. Now this other formula, we're going to do the same thing for the other one. It was 1 plus an plus n take 1 over the factorial of 2 times a squared plus. Now, I'm not looking at a sheet for this, I've just remembered this off the top of my head. I actually have. And then you add n is it the factorial then? Sorry. Oh, I've not done a good job doing it off the top of my head actually. Let's get into that. No, it's just factorial of 2. Yeah. Doing it right, shouldn't stop myself. N take 1, n take 2 over the factorial of 3 times a cubed. And you keep adding like that until this reaches that. So in this one we'd stop at this. Now it should theoretically give us the same answer that we found out before. Now, if you want to find out the answer and prove it to yourself that we get the same answer, you just sit back a few seconds and write down the answer, and I'm pretty sure we'll get the same one. Now this, it has to 1 plus a to the power n. Now it has to, that's what it has to start like. So, as you can see, it has to have a 1 at the start. I know I told you how we can get 1 before, but it has to have a 1 plus a to the power n. It can't have a 2 plus a to the power n. Otherwise this formula wouldn't be right because of this bit at the start there. I won't circle it actually. Because this is based on the premise that begins with 1 plus a to the power n. This is not necessarily always the case. So, otherwise, generally, for any other formula, they want you to use the other one, where they put 2 plus a. They don't generally make it so difficult that you would not be able to complete the binomial expansion if it was say, a negative number I don't know, as n, and it had 2 plus 6x, for example, in the equation, it wouldn't necessarily be that challenging, I don't think. I've never seen one like that. I would just go with the premise that it's going to be 1 plus a to the power n. If it says 1 at the beginning, you always use this formula, and if it's it can be a positive integer for this one as well as like the other one. But if you had 1 plus a to the power n, you'd use this one if it was a positive or negative. Just as long as it's got 1 plus a in the brackets, you'd use this one. Otherwise, you could use the other one, hopefully providing the answer n is positive. Now n is the power, and now this is cubed, it's positive, so we'd use it one. So let's put this formula into this, and we should get that, you know, the 8x cubed bit on the end of it as well. So 1 plus a times n, so 2 times 3, which is 6, 1 plus 6, and then is that 1 to start with actually? Yeah, and then n times n take 1, so n, which is 3, so 3 take 1, which is 2, over the factorial of 2 times 1, times a squared, which is 2x, so 2 squared is 4. Now, you don't need to do, I didn't write there, I'll zoom it in actually, so you know what I'm pointing at. No, I didn't, when I was doing it there, I didn't write 3 take 1, otherwise, when we start doing like this there, and we get past a cubed, if it was asking that, it's going to get a bit complicated in the sense that we'll be writing a 3 take 2 and we might get confused. So what I'd do is just do 3 brackets 2 brackets 1. Now there's a good reason why we stop when, actually that's just sort of helped me to explain it. So there's a good reason why we stop when we get to a cubed. Oh wait, actually, is it when it's that? I don't think it is. Sorry, let me just yeah, right. So we stop in this. Oh, it's awful. My face is straight in there. Right. So we stop this formula page thing when we get. So we've got 3 times 2 there, and that's because we've taken 1 away from the n. As you can see at the top part of the formula, and then that's going to get us, if we did that, which is going to get us 3 times 2 times 1. Yeah, we stop when that a cubed, when the number above the a is equal to n, and that's because if we did the next set after this, so actually I'll carry on with it, wish time. So we've got here 3, 2, 1 over the factorial of 3, which, sorry, I don't know, I was looking there, 3 times 2 times 1 times a cubed, which would get us, sorry, let me think of it, a cubed 8, don't know actually, let me think of it. Now we could not possibly do, we can't do another one of this, because if we did, let's just do the next one. I'll do the next step and prove to you why we can't do, why we can't go past a to the, that bit there where it says 2, we can't go past that being larger than n up there, and this is because, so that's our largest we can do. So hopefully you're starting to see where this is going. So if we did n take 1, n take 2, the next one, bracket, will be n take 3. Now if we take 3 away from 3, we're going to get 0. So it would be 3 times 2 times 1, and then we times it by 0 over, yes, it would be the factorial of 4, 4 times 3 times 2 times 1, and then we times it by a to the power 4, so 2 4 is 16, Now that'd be 0 divided by the factorial of 4. Anything divided by 0, hopefully from your basic maths knowledge, is going to get you 0. So any other step we do after that, no matter what the factorial is on the bottom or what we're timesing a by to the power, we're going to get 0. So it's pointless doing any more steps after this, because all we're going to get is we're going to be adding 0 on each time. So we could do the next 1,000 steps after this. It wouldn't make any difference to the eventual answer. So I'll get rid of this bit, because hopefully I've explained it why we don't use that. Sorry. So I'll get rid of this. Right. So what we should do, A to the N. I think I've messed this up somewhere because there's no X's in there. Sorry, give me a minute. Right. Yeah, that's where I've messed up. So A here is 4x squared. Sorry, just I didn't put the x in there. So that'd be 8x cubed. So let's expand this out. So we've got 1 plus a times n. Sorry, 1, that'd be 6x. 1 plus 6x plus 6 over 3, which is 2, times x squared, which is 8x squared. Yeah, 3 times 2, 6 times... Have I done this right? I think I might have done this wrong somewhere. Let me just check. So just give me a minute, I'll make sure I've not done this wrong. I hope I haven't done it wrong. Yeah, I've done it right. 12x squared. Wait, right, we've done something wrong here. Times 4. That should get us 12. Sorry, I'm just trying to figure out why I've done it wrong. There's 4x squared. X squared. A squared. Three times 2 times 1. Sorry, I'm just making sure I've not actually gone over and messed anything up. 3 times 2 times 1 is 6. Oh dear. Just my laptop, man. Probably damaging itself. So 3 times 2 times 1, 6 times 1 is 6, 3 total 3s is 6 times 6 over 6 is 1 plus 8x cubed, so that's alright. 3 times 2. So this is, that's right, I've done something wrong in this one here. But we should get 12x squared. So as you can see, we've got exactly the same answer either way. Apart from my little mess up in one of the calculations, but we've got exactly the same answer either way, whichever way we've done it. So that's the basic, pretty much all of the binomial expansion you need to know. I could do some past paper questions now, but I think I've wasted enough of your time. You've probably had enough of life by now. That's the basic way of doing a binomial expansion. I hope to see you in the next video.